We are live and we are recording. So today the topic is translations of parent functions. Okay, write that down. Translations of parent functions. All right. So, our parent functions are these: constant function, linear, the quadratic, the cubic, and the square root, right? These are my constant functions. So, if I look at example 1, and I need to graph example 1, and I could do it with a calculator, really could, but I can do it faster without a calculator, okay? So, it's an x squared, right? You guys agree with that? So, it's this graph here. So if it's this graph here, and then plus 2, we're going to take and move this entire graph just up 2. That's all we're going to do. We're going to take this graph. We don't need a calculator to do this. We can just take the parent function and move it up 2. So I'll put the vertex, which was at 0, 0, and I'll move it up to 2. So I just took this vertex and moved it up to 2. And then I'll do the same graph. 1, 1, because 1 squared is 1. 2, 4, 1, 2, 3, 4. 3, 9, but 3, 9 is going to go off my paper, but 1, 2, 3, 4, 5, 6, 7, 8, 9 is up here somewhere. And of course it's symmetrical. And there it is. So all we did is we took our parent function, or x squared, we moved it up 2. That's it. Okay, example 2. X minus 1. Okay, now we learned yesterday that if it's on the inside, we're going to move it horizontally, but the opposite way. So I'm going to take my parent function. It's an x squared, right? It's an x squared, so I'm going to take my quadratic and I'm going to move it, okay? What I'm going to do with this one, though, is I'm going to move it, instead of back 1, we're going to move it to the right 1. Because we go the opposite of the inside, because it's what zeroes it out. So I'm going to take my parabola, and instead of starting the vertex at 0, 0, I'm just going to bump it over 1. So what I'm going to do is just bump it over 1. So I'm going to put this vertex here over 1 because of the 1 here. And I'm going to graph it the same way. 1, 1. 2, 1, 2, 3, 4, 1, 1, 2, 1, 2, 3, 4, and then 9's up here, 4, 5, 6, 9, 9. And it should look like this. Okay. Okay, all I did is took my parent function and moved it horizontally to the right, because it's the opposite of the inside. Opposite inside. Okay, what about example 3?
Then you go up 2 over 1.
Yeah, you guys did the same thing but backwards, okay? You said over 1 up 2, and I think somebody said up 2 over 1. So it puts us in the same spot, doesn't it? Totally right. So you combine both these, okay? See if you can graph it, okay? I just heard that. So if you put the vertex, I heard over 1 because of that negative 1, and up 2, here's your vertex, right? Okay? Try and graph it, okay? So you're going to take your parent function, which is your x squared. You're taking your x squared to graph, and we're just moving it, the vertex, to here. Over 1, up 2. So we're going to go over 1. We're going to go right 1, and up 2. Totally agree. See if you can get it. Okay, should look something like this. 1, 2, 3, 4. 1, 2, 3, 4, and so forth and so on. Okay. Okay, raise your hand if you got that. Good. Good, 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 good. Girls, you getting it? God bless you. How about example 4?
You're gonna go down 1.
So we're gonna go still 1, 2. We're gonna go over 1, up 2. Still, right? So we're gonna go right 1 and up 2. And we know it's a parabola because of the x squared, right? It's got to be. But what about this negative? What's this negative mean? What the heck? What's this negative here mean?
It's going to go down.
Julia, say it. I saw you do it. Say it. You're going to flip it. So it's going to be upside down. It's going to flip over the x-axis. So we're going to flip. So this negative right here means to flip over x-axis. Totally right, Julia. So instead of 1, 1, we're going to do that whole 1, 1, 2, 4, and the 3, 9, but upside down. So 1, 1, but upside down. 2, 4, but upside down. 1, 2, 3, 4. 3, 9, but upside down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, we'll have the points on the other side because it is symmetrical. So each of these little symbols did something. The squared, the little tiny squared meant you were going to graph the quadratic, right, or the parabola. The -1 was a horizontal shift, but forward 1 or to the right 1. The 2 means pull it up 2, and the negative means upside down, okay? Example 5. Am I going too fast? Or am I okay? You guys ready for example 5? Square root of x minus 3. Let's see, what's the parent function look like? Okay, the parent function looks like this. Remember this parent function? Here's our square root of x graph. What are we going to do with this graph here? What am I going to do with the x squared minus 3?
You're going to move it right 3.
Actually, let's move it down. It's not on the inside. Let's move it down 3, okay? So it's going to start at 1, 2, 3, down at -3, okay? So I want to take this picture, this square root graph, this function, and move it down 1, 2, 3. So I'm going to start it down there. Okay, so how did I do square roots? Well, let's use square root numbers. Square root of 1 is 1, right? What's the next square root number I can do? What's the next? Give me a square root number. 9's good. Give me the one before that, though. Yes. 4. 1, 2, 3, 4. And what's the square root of 4? 2. Now, Julia, what are you going to give me? 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3, okay? There it is. All we did is we took this graph, our square root graph, and just brought it down 1, 2, 3, and graphed it. See how I did that? I took my square root graph, and brought it down 3. Okay, now, example 6. What are we going to do with example 6?
Move it up.
We're going to move it, not up.
Okay.
It's on the inside. So if it's on the inside, it's going to be a horizontal, but the opposite way. So I'm going to move it to the left 2. I'm going to make, so because it's the opposite of that, opposite, we're going to go left 2. And then what about the -3? What do we do here? Down, and then down 3, right? So I take the very end point, take my very end point of the square root graph, and I'm going to move it left 2, down 3. So I'm going to take this, I'm going to go 2 and 3, so I'm going to put it right about there, okay? So I'm going to take it, go left 2, 1, 2, and down 1, 2, 3. So I start the very end point right there, and I do the same square root numbers, like the square root numbers. So starting at its end point, if I go over 1, what's the square root of 1? 1, right? If I go over 2, square root of 2 is like bad decimal, square root of 3 is bad decimal, but square root of 4 is 2. Julie, what's the next number? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3. You can even go 16 and 4, but that won't fit, right? So there it is. Okay. Ready to turn the page? All right. Okay, here's a cube. Let's see. Let's take a look at my parent function. Here's my cubic, right? And what I want to do is real quickly just I'm going to highlight this point right there. That's kind of like the middle of the graph. You see this orange dot? This is what we're going to move. See how it kind of bends right there? So this is the point I want to move. This is the point at 0, 0, okay? So on this one, I'm going to move it where? How am I going to move it? I'm going to move it horizontally, right?
When do you move it vertical?
If it's on the outside, like that one. Okay? Horizontally, but opposite direction. So we're going to move it to the left 3. We're going to take it to the left 3. Because if it's on the inside, it's a horizontal movement. It's always the opposite, okay? So I'm going to take this graph and move it back 3. So this bend is going to be right about here. It's going to go, see how it's going to bend right there? So I'll put this point here. And I'll do my 1, 1, 2, 8, 2, 8, because 2 cubed is 8. 2, 3, 4, 5, 6, 7, 8. It's going off paper. 1, negative 1. Then negative 8. And it looks like this here. The little bend goes right there.
How'd you know I'm negative? Oh, because that's
Right. I have to get the whole graph, right? Does that make sense? Plus a negative times a negative times a negative is a negative. That's why I went down, right? A negative times a negative times a negative. Because I'm cubing it, right? Yeah. How about number 8? How about example 8? What do you guys think? Where are we going to put this middle point? Where are we going to put this middle point at?
We're going to put it at -2.
So we're going to go back to negative 3 and then up to 2. Okay, because we go the opposite inside, so we're going to go left 3, but then up 2, all right? Because you always have to do the opposite of the inside. The inside amount is always a horizontal shift. So then here's what we got to do. Okay, so let's go left 1, 2, 3, and down 2. Okay, so since it's a cubic, it's this graph right here. So I'm going to move this center point to negative 3, 2. Right? So we'll get the same graph. 1, 1, 2, 8, because 8, 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8. I'll do the same thing. Negative 1, and 8. So it looks like they're get a little bendy there, okay? All right. All right. Let's play Jeopardy. Here's the answer. Give me the question. You know Jeopardy? You'll say, the question is, they give you the answer, you have to come with the question, okay? So, Alondra. Oh my goodness. Alondra, I made a mistake. Thank you. I'm so glad you're in this. I did make a mistake. And it's caught on film, too. Load that up. Say, okay, we caught Mr. Davis making a mistake. It's on film. Thanks, Alondra. Back 3, up 2. You're right. Good thing I have white out, huh? You guys agree? I agree with Alondra. Thanks, Alondra. Because when I didn't go up 2, I went down 2, didn't I, Alondra? Okay. Fix that, and then we'll talk about the next one, okay? Last 2 examples. Okay? So, let's make an equation. F of x equals what? What kind of graph is this? What kind of graph is this?
It is a square root.
It's a square root. So let's start there. Square root, okay? Let's start there, okay? Square root, okay? Now, has it been moved back and forth? In fact, it's been moved back 2, right?
Back 2 down 1.
So it'd be an x plus 2, and it went down 1. Now the plus 2 came from the fact that it's the opposite. This is the equation for that. All right? How about the last one? F of x equals, what's the parent function? It's an x squared, right? So it's an x squared. Okay, it's an x squared.
-1.
It is going to be -1 is totally right. X -1 is totally right because it's the opposite, right? We went forward 1, and then what's on the outside?
-2.
Minus 2 is right. Okay, now, let me show you one more thing, and I promise I'm done, okay? So, you get to a quiz, almost there. Get to a quiz, and you totally lost, right? You have no clue. Can the calculus do these? Yes. Watch. Y equals, let me do the first one. If I do x variable, x squared plus 2, there it is.
Wait, how'd you get to that first screen?
I'll do it again. Y equals, parentheses, x variable, subtract 1, parentheses, squared.
Wow, that's
Okay. Y equals, let me do this one. Negative x subtract 1 squared plus 2. Graph. Pretty cool. How about this one? Y equals square root of x subtract 3. So you can also do these on the calculus. Isn't that neat? I can do it faster though without a calculator. I'm hoping you guys can too. Okay. Anyway.